In the distant past, when blue, white and green LEDs were first becoming affordable on eBay in bulk packs from companies like Triwing and Best Hong Kong on eBay, I was I was building a lot of them into props, and I discovered at that time that there were such things as unreliable LEDs. Well, we all know about that now because, well, gallium nitride introduced unreliable LEDs. And also, the ones we were getting were often defective LEDs where the position of the chip was wrong in the lens. It was basically, they were just the cast-offs that were available to the likes of us. So I made a device that I called the LED Comparator that could switch between two LEDs. And that meant that you could point this at a wall and you could switch between the two LEDs and compare their beam angle and their intensity. You can see with this one, for instance, that it's actually a huge difference in intensity of the same current. But something went terribly wrong. During the making of a video called the Dubious Butane Bubble Tube Experiment, I was basically filling bits of silicon hose, like aquarium tubing, with butane lighter refill gas. And I was corking the end with LEDs because they were a good fit for it. And I didn't realise a couple of things. I didn't realise that butane attacks this type of plastic because, well, the project involving high pressure butane often exploded and stuff would just squirt out every orifice. The LED would come out with a bang, followed by a cascade of the fuel. And initially nothing really major happened, but latterly the plastic just started breaking. It's gone super brittle, the LEDs fell out. I think it's time to make a replacement because this is still a very useful device. So let's open it up and I'll show you the inside of it. It was very crude, it was just rattled together. But it is still extremely useful, as I'll show you afterwards. I'll test some LEDs once I show you the newly rebuilt version. I will be using some of the screws. I was going to use the switch in the battery contact, but I've since found a switch, so I don't need to do that. So battery, bit of foam stuck in, random wedge of foam, which also seems to have been attacked by the butane. A switch and some resistors, and then just two Molex style connectors marked. Well, they were marked red and black, but the black is completely worn off that one. That's quite strange. Okay, let me show you the schematic. It's not that complex. We have the 9-volt battery, a PP3, and the positive goes to a resistor 330 ohm, and that then goes to a two-way switch which switches between the two LED sockets. I'll just show them as being sockets by putting those little sort of contacty type things on. But there was one extra thing. I initially had a high value, it was a 100k resistor across those contacts. So whichever one wasn't switched on, the resistor would feed out of that low current. And that low current was great for testing because when the gallium nitride LEDs fail, or when you get a bad one, if the film's faulty, they may light at full current, but at very low current they won't light, and they'll often flicker later on and cause problems. So that was a simple way to actually test if there's a problem. However, this time I'm going to put a higher value because modern LEDs are much more sensitive. I'm going to use 1 megohm, but I'm going to use one on either side so that each one is just, it just makes assembly that little bit easier. Well, that was badly drawn. So there it is. So the sockets will be both driven via 1 megohm resistor at all times, but the switch will switch the higher current from one to the other so you can compare the output. That is it. That is the circuit. Now you could use one of these little boxes with the battery compartment built in, but I thought, and this is strictly optional, I thought I'd 3D print a case for this with all the compartments built in. Strictly optional. I'll put the script for this, the OpenSCAD script for this, down in the description down below if you want to build one of these. It is kind of optimized for the Molex style connectors. I call them Molex connectors. They're universal connectors that Molex also make. So let's start building it. The solder iron is up to temperature. I'm organized. This is good. So I've already put some crimps on some of the connections. I've still got one to put on. So I shall put that on now. And I'll zoom down just a little tad, just to make things more visible. Sound of a file rasping across other tools. So I'm going to pop a little crimp in here, snug it in, Put the wire in, making sure the strands are all nice and square but not twisted. I used to twist the strands before putting them into crimps. It turns out that's not what you do. And crimp it. So that's the last one. But you also have the option of soldering them, and you don't have to use this connector. You can use any connector you like. This is so simple you can just rough out of anything really. Now I'm going to, there's the positive, so I'm going to put the positive in here and the negative in the other side. And likewise with this connector, I've marked this side red, so I'm going to put the positive in that side and the negative in the other side. The script lets you choose the diameter of this hole. I actually just set a base size of 5mm, but then I just drilled this out to 6mm because that's the size of switch I found. In hindsight, I wish I'd dug the switch out beforehand because I'd have added the little extra hole or just a recess, partial hole the other side for this alignment ring that has a little indent that just sticks down into the sort of hole that you can, so it can't rotate. It doesn't really matter. It's not needed. Now the question is, do I put this in and then try and solder? No, that's not going to work. No, let's not do that. Right, so let's start. So I'm going to switch the positive. So the two positives will go to either side of this switch, so it switches between them. So I shall strip these wires. Now, I could leave these full length and just make a huge mess inside. You know I'm going to do that because I'll cut them a little bit shorter, but I want to leave as much as possible because it just makes it easier. And I've left loads of space in this case, despite the fact it's a much smaller case than the previous one. It's all generously sized. The battery compartment is especially generously sized because you know what it's like when you get these products with tiny little PP3 compartments and you get the battery and it just won't fit in, or you fit it in and it's friction fit and then there's nowhere for the wire to go. I don't like that. When we're designing stuff ourselves, we can change that. We can make it better. So I'm stripping these all to roughly about 5mm, just under 1/4 of an inch. And the blacks will twist together and they'll go straight to the negative terminal of the battery. The positives will go one to either side of the switch, but they'll also go with a 1 megohm resistor. So I'm going to put the 1 megohm resistor in there. Oh, you know what? This is probably going to be easier. I'm going to put the 1 megohm resistor there, the other 1 megohm resistor the other side, and then I'm going to get the 330k resistor that goes to the middle one, and I'm going to just basically twist them all together. I'm not sure this is a good idea, but I'm going to do it anyway. I'm sure it'll fit. It may not fit. I may regret this. Right, okay, I'm twisting them all together. And I shall crop that short, and that will be the positive. They're going to kind of support each other. I think that's going to work all right, actually. Rightio. So the first one that actually gets soldered then is the middle one. And then I shall poke the positive wires through either side. This is where I discover that I didn't look solder out before starting. Yes, I've got a bit of solder. This is a good starter bit. It's an offcut from a previous project. I do use all solder. I don't waste any. All solder is precious, particularly in this era of lead-free solder. This is not lead-free solder. That's why it's flowing so well. Oh, look at that. Isn't that marvellous? If it had been lead-free, it would have been crap. I may just be exaggerating things a bit. Now I'm going to fold these wires down like that. I'm going to crop them to size. And I'm going to stuff the little red wires through as well. Oh, you know what I should have done? Joe, it would have been great before doing that. Actually soldering these other ones, now they've all popped apart. That was very ill planned. Not to worry. I can fix that right now, he said, lying very slightly. I shall sploosh them together with solder. They are now slightly misaligned. That's okay. It's what happened. When projects go wrong, you improvise. Okay. So now I'm putting the positive. I'll twist the wires this time. Oh, that's quite hot. That's not really surprising. I just previously heated it to 330 degrees Celsius. So it would be quite hot. I'm going to stuff the wire through, and then I'm going to solder both the red wire at this end and the other lead of the 1 meg ohm resistor that's tucked in there. Are you catching this all right? Are you able to see it all right? You get the gist anyway. Now I shall flood some solder onto that, trying not to destroy the switch in the process. Putting a slight excess of solder in that, but not to worry, I have no regrets. This is actually quite pleasant. Can you tell that it's just a chill out project? This was such a useful device. I can't even start to tell you what a great device it was for doing very precise comparisons of LEDs. You could fine tune, you could actually go through the whole collection of LEDs and just work out which was absolutely the brightest, which was essential at the time. Or, in some instances, which had the nicest pattern. Some of them were very sort of swirly. They projected swirly beams and it wasn't very good. Although you do tend to diffuse LEDs in television and film because in props, because if you don't, they can glare. They can really mess up the intensities in the camera. This is looking great. I'm saying that. It might not turn out great later on. But right at the moment, it is looking great. Rightio. Now I've got to make a decision. Here is a battery. You know what? I'll use the original battery. I don't know how old it is. Memorex Energy. Does it have a date on it? Used before 2011. Tell you what, since that's 10 years out of date, maybe we'll treat ourselves to a new battery. One moment, please. 2029, that sounds better, although what's the bet that this one will leak before that one does? But hey, you know, it's what it is. It's one of these generic Kodak branded. Kodak, who went bust so long ago when film became unfashionable. Yet the brand still lives on. Now I've got a choice of connectors. I can have the one that comes out like this, or the one that comes out this side. I incorporated a little slot in here for the cable, so I shall use the one that comes out this side, I think. So I'll just fold these wires out the way so that they don't touch anything. I shall pop that in there just experimentally. Oh yeah, I can actually, I can lose the whole lot of the wire in there. That is pretty good. That's all right. Rightio, I shall pop that off before I end up shorting the wires. In that case, I'll shorten the wires a little bit, but not an awful lot. It doesn't need to. Do you know, I should have actually got a bit of heat shrink, but not to worry. I didn't. I shall get it later. So let's strip this. This is a generic little wire stripper. I can't tell you what brand it is, but because I'm holding it over the label, it's a Draper, which is a generic cheap brand here, sort of Harbor Freightish in America. But it's fine. A lot of their tools are perfectly acceptable for the less demanding applications. It's not quite up to the standard of Snap-on, but then again, Snap-on is just an image, isn't it? I mean, their tools are okay, but it's one of these things that the reason you get a free replacement is because you paid 10 times the normal price in the first place, and sometimes you're better just getting some tools that are cheaper. However, the tools you use an awful lot go for an expensive one, because go for a better brand. Like, say for instance, the side cutters and things like that, get Nipex. That's who I choose, Nipex. I've tried various brands and they tend to come and go with the brand quality, but it's Nipex at the moment. It's probably, people are going to say it's actually pronounced Nipex now. Now I'm going to twist all the blacks together. That sounded very slightly racist. But they are together. Black twists matter. And these are all the common negative. This project is so far on, it's like ridiculous. This is not a complex project. Right, tell you what, I'm going to get a bit of heat shrink for this because it's begging for a bit of heat shrink. One moment, please. Black heat shrink, it seems appropriate for this task. I shall crop it down about that length, slide it over the solder joint and a good chunk of the insulation too. Then I'll show you as my little heat gun, or a solder iron, or a lighter, or whatever you've got. smoke him if you got him. Just whatever you've got. Improvise. Am I going to get hate from all the snap-on guys now, the aficionados? The ones who feel empowered by their £50 spanner, crescent wrench, whatever you call it. Apparently crescent wrench is a brand. Rightio. Now I'm going to stick this in here. Is it going to fit? Is it going to fit? Yes, it's going to fit. So I'm going to put a little packer on. This nut is going to basically hold it at round about the right height in the case. I'm not too bothered. Somewhere like that. I could put I'll put this springy ring on top just because it looks quite nice. The serrated washer. It adds a touch of serratedness to the finish. Those resistors are on the borderline. They're just touching the side of the case. In that sense, maybe I should have skewed that thing up a little bit, but it doesn't really matter. Screw it. It's how it works. It's just going to work out fine. It's looking very nice, I have to say. I did consider going all fancy with the case. I almost put myself off this project by trying to be over fancy with the case and putting curvaceous edges on it, and then I thought, no, I'm just going to do it like a big block because it's a prototype. I say that because it's because I'm only going to build one. It's like the prototype. I'm not going to make another of these because I don't need it. That's looking just fine. I am regretting not using this little indent thing to hold it in place just because it would have been quite nice. Right, that is it. So now I put this battery on and smoke comes out and I tuck the wires down like this and I'll get these two LED thingies. So I'm going to put an LED in one of them. It's either going to be bright or dim. It's dim. That's the one that's being fed by the 1 milliamp. I flick the 1 megohm, should I say. I flick it, it goes bright. So that switches over that direction. So I want that socket to go in there. And this is where I got all very clever and I did design a little recess that these will just slide down like that. The 3D print messed up. It didn't produce a very nice edge there, but that's all right. It is just a prototype. I'm not one of these aficionados that fine-tunes things. I'm the person who actually just designs the file and prints it. And this is looking pretty good. I will say that cable needs just folded and mushed up a bit. Just to make it stay down. Stay down. How's that? And then this is the special bit. So when I put this in, these little prongs will actually hold those in place. I'm quite proud of that a little bit. It worked. I did the measurements raw and it actually worked perfectly. That's perfect. So if I stick the other LED in here and then flick over, excellent. Rightio. I'm going to put the screws in and then I'll show you how you can actually test the LEDs to see the brightness. This is where I find out if my holes, I may have used too much or too little infill in the solid objects. It kind of affects the strength of the self-tapping the holes, but I shall go gentle. I was going to put big fat pillars up there for these self-tapping screws to give them extra plastic, but this is looking pretty good. A little bit of foam in there to stop it rattling would have been nice, but who cares if it rattles? If it rattles, it rattles. It lets you know there's a battery inside. Well, look at that. Isn't that quite neat? That is quite neat. I'm quite proud of that. That is nice. Solder iron off. It's not needed on anymore. Right, I'm going to go and get a medley of LEDs and show you how it can tell the difference between them and how it can test them and also how it can tell what's a good LED and what's a bad LED. I'll be back in 1 moment. Okay, let's test some LEDs. I think I shall start off with the greens. So I've got 2 Triwing Greens and I'm going to load them into the unit. two different ones, claiming to be different colours, but not really being different colours. So Triwing was a company that sold bulk LEDs on eBay. The main rival on eBay at the time, like a decade or so ago, was Best Hong Kong. Best Hong Kong had that really annoying habit at the time, before eBay clamped down this, they'd say something like £5 or £10 100, which was a good price at the time. But then you went to buy them and added £20 or £30 postage. It was just a ridiculous markup. Right, tell you what, I'm going to dim this down now. Take the exposure off, lock that. Okay, so here's one LED. There is a distinct colour. That one's more of a washed out green than this one. Which is I'll use this one as the reference. So I'm going to keep this one as a reference. Let me show you what I mean about the testing at low current. That is just one, it's about 6 microamps, I think, with that 1 megohm resistor. And that, if that LED was faulty, it wouldn't be lit. So I'm going to keep this one in, and I'm going to put in a generic, like the real 100 for £1 type LED off eBay, the really super cheap ones. So this is the modern cheap one from eBay. That's the old Triwing. Modern cheap one, old Triwing. They have come on in leaps and bounds. That is ridiculous. So you can see here that it's not just brighter, but it's a nice, rich colour as well. Okay, let's move on to the next. Exhibits. Triwing white versus cheap bulk. 1000 LEDs for not much. 200 of each colour. And these are the cold whites, and the white is where you really see the difference of the old LEDs. So this is modern white LED. This is old one. Modern white, old one. Modern. So I think I'll be choosing the modern white one. Better beam spread, better colours, and that big blue dot in the middle. And then that nicer colour. That's not a bad colour for cheap generic LEDs. That's not bad at all. Well, let's give them a test. This is the one. It is just glowing very slightly. Let's give the cheap generic eBay a test at the super low current. If I can see to put it in. Oh, it's quite bright, even at that tiny current. Okay, now I'm going to try generic cheap Chinese blue, but I'm going to be trying it with what were quite expensive LEDs. I got these Vivid LEDs. I got these from a company in China, who were a real LED company, and I sold them on a website. And the quality was a lot better. That is pretty good, actually. For the time, that was an outstanding LED. That's the cheap one. That was the old expensive one. Cheap one, old expensive one. Slight beam pattern difference. Softer, the older one is a softer image. The other one's a bit more sort of hot spot. And now two recent LEDs. Random warm white from eBay. So I'll plug that one in, and you can see it glowing, it's fine. And this is a AliExpress one. It's a really big dish. You can almost see it there, that it's got a much bigger emitter in it. Well, a larger dish. I'm not sure if it's a bigger chip. It is like chalk and cheese. That's the AliExpress one. This is the eBay one. I suppose they probably sell on eBay as well, but for the same current, they're both drawing the same current. There's a massive intensity difference. These are straw hat LEDs, by the way. If I pull this one back, it's bright, it's dimmer, bright, dimmer. It's a huge difference. But you can see now that this tool is very useful for comparing LEDs and just choosing the brightest or the one with the correct beam pattern. And it lets you fine tune in a dark room if you toggle backwards and forwards between them very quickly. Watch your eyes, the light's coming back here. And the light is back. If you toggle from a distance onto a wall, back and forth between them, you can actually fine tune. You can decide exactly which batch of LEDs is the best suited to your needs. But there we go. The OpenSCAD file for the case and the lid are down below in the description of this video. But you can also, as I say, just use any box and just about any switch you can find. So just, you can just rough it up out of absolutely anything. But that's a very neat and very useful device. The LED Comparator. Very useful indeed for that fine tuning and selection and comparison of LEDs.